Hello, my name is Mark Sweetgall, and I am a program manager at Microsoft focused on Windows on ARM. I'm here to give an introduction to Windows on ARM development. In this talk, I'll talk about the benefits and basics of Windows on ARM as a platform, go into how to think about building your app for Windows on ARM, and then what to know that's maybe different from building for Windows on Intel. And so, Windows on ARM, or what we sometimes call the Always Connected PC, is a great option for customers that takes the best aspects of what you might like from your phone and adds them to your laptop or two-in-one. And first, these are full Windows devices. They are not restricted in functionality in any way. You can have Windows Home, Pro, Enterprise. You can run whatever apps you want. You can manage it the same way you'd expect to manage Windows. It's just Windows, and that's awesome. But then, thanks to the ARM processor built by Qualcomm, these devices have fantastic battery life. And while travel isn't maybe the same as these days, it's still such a relief to know that your device will still work even after you've used it all day, either on a plane or on a couch. Then another perk of collaborating with Qualcomm is that cellular connectivity isn't an afterthought. Devices that have LTE or 5G connectivity have that support fully integrated. It just works. And that means you can be seamlessly connected wherever you are, always up to date, always have the latest. And finally, these devices all have instant on. You open the lid and you're just ready to go. And if you think about it, you wouldn't expect anything less from your phone. So why do you accept less from your laptop? And now we've been on this journey for Windows on ARM alongside Qualcomm and our OEM partners for a few years. And over time, we've seen this portfolio of devices continue to expand and to allow customers with different needs to find something that's right for them. On the high end today, we have devices from HP, Acer, Samsung, Lenovo, and Microsoft with the Surface Pro X. I personally use the Galaxy Book S and the Surface Pro X for most of this presentation. Then there are also new devices in more mainstream entry-level price points, including the extremely affordable Snapdragon Developer Kit that we announced this year at Build to help developers bring their apps to ARM. And so let's talk about apps. I mean, that's why we're here, and Windows is all about apps. So Windows on ARM includes an emulation layer so that existing apps can run even if the app was built years ago, has never heard of ARM, doesn't know what it is. And so regardless of if you get that app from a website or from the store, the emulation will automatically and transparently just make the app work. And that means with a Windows on ARM device, the whole ecosystem of Windows apps is available to you. And that's massive. Now, the main caveat is that any drivers must be compiled as ARM64, since those can't be emulated. Now, Windows 10 on ARM supports 32-bit x86 applications, and it's supported them since the platform first launched. Windows 11 on ARM adds support for 64-bit x86 applications, I'll call x64. It adds support for x64 applications as well. And now, I love to talk about emulation. I think it's a really amazing and interesting technology, but that isn't the only option for apps. So we've optimized the emulation as much as possible to make it super efficient, but apps compiled specifically for ARM fully unlock the power of the processor in a way that emulated apps may not. So Windows 11 also adds support for ARM64 EC, which is a new way to build native apps that are fully interoperable with x64 code, and we'll talk more about them later. But first, I want to call out, with all this momentum around Windows on ARM, and as that momentum builds, we've seen more and more apps get built for the platform. In fact, since the last Dev Summit, you can see all of these apps that now have native versions, and it's by no means an exhaustive list. It's just been really exciting to see these major software vendors bring their apps to ARM. And so that's where I'll make my broad proclamation for the day in the largest font I could find. And that is, you can build your app for Windows on ARM. It can be done. So let's dive in. Now, first, I'll quickly mention, if you are building new apps with the Windows App SDK, formerly Project Reunion, you may have already seen this slide of various investment areas and features in those tools. And you'll notice that ARM64 support is right there. Building for ARM64 with the newest tools is a straightforward and core part of the experience. But what if you already have an app for Windows that you want to bring to ARM? And here's where I think it's important to take a step back and think of the overall picture. Specifically, native code is going to have the best performance, but emulation is supported long term. This is Windows after all. Our compatibility is what we do. We want to keep apps working and keep people happy. So if you're bringing an app to ARM, you should start with the parts that have to be native. In this simplistic diagram here, I have this theoretical app that includes a driver as well as a plugin that gets loaded into an ARM64 app. And both of those pieces need to be built as ARM64. But after that, you can start to be strategic. Take pieces of your app and port them to native to get the best performance. At each step, your app would get faster, and the hope is that you would end up with a fully native app that delights your customers with the best performance and battery life. Now, the picture changes a little bit with Windows 11 in a good way. First, Windows 11 adds support for x64 and ARM64 EC, as previously mentioned. And to explain why ARM64 EC is important, it's first worth thinking about what it means to go from x86 to ARM64 today on Windows 10. And so I talk sometimes about going piece by piece, but with x86 to ARM64 on Windows 10, it's at a process level. When you're doing that port, you need to recompile all of the code in the process. That means all of your code, any dependencies, and then any plugins that might get loaded into that process also need to be ARM64. And I might be unintentionally making that sound daunting. I really don't mean to be. That transition is totally doable. We've seen great uptakes in software vendors doing exactly that. We just saw that a few slides ago. But we think it could be better. And with Windows 11, ARM64 EC provides the opportunity to take that piece-by-piece approach to the next level. See, ARM64 EC is native, but it's compatible with x64 code in the same process. And that means you can have a mix of emulated and native code in the same process, effectively making the nativeness of that process, for lack of a better word, almost a spectrum rather than a binary or one or the other. And so you can start from a fully emulated x64 app and then port to ARM64 over time, bit by bit, improving your performance as you do so. And you might hit some place along the spectrum where your app is mostly ARM64 EC and you get a great experience for some amount of effort, and you can continue to improve over time. And when you approach the problem that way, you're no longer looking at the process level, and you can instead think of your app as being like a bunch of smaller blocks that you port to ARM64 EC piece by piece, incrementally making the app more native, faster, better battery life as you do so. And critically, this also means you can leave x64 dependencies as x64 if needed. So in this, again, super simplified diagram, I've called out a few pieces. There's an older dependency in the top right. It's still x64, and that's fine. On the other hand, I have a chunk of performance critical code, and that's something you'd want to prioritize building as ARM64 EC, because that's going to have the biggest impact on your customers to have that running natively. And then maybe you have some custom x64 assembly, and that can stay x64 for now, and eventually you can port that to ARM64 EC. The key is that you have the flexibility to make progress and focus your efforts where you can improve your app's experience the most. Using ARM64 EC also makes it possible to retain compatibility with third-party plugins, which is essential for some apps that have ecosystems of them. So 64-bit Office, for example, is using ARM64 EC to get great performance on Windows on ARM, while still supporting their massive catalog of x64 plugins. So the tools for ARM64 EC are in preview now. So if this approach is of interest to you, we totally welcome feedback to help identify any remaining gaps, any remaining bugs, so that we can improve the tools and by extension, improve your apps. So let's take a quick look at ARM64 in action in this demo. I'm a longtime fan and user of the app Notepad++, which is a great text editor with a powerful plugin ecosystem. So what better way to show the x64 compatibility of ARM64 EC in action than this version of Notepad++ that I've built using the ARM64 EC preview tools. First, you can see in Task Manager that its architecture is listed as ARM64 x64 compatible. Peeking at the built binary itself, you can see that it's made up of ARM instructions. And when I use the app, I find that it's got great native performance. But critically, it also has a long list of available plugins built by third parties. I've already installed one such plugin, Explorer, which you can see is x64 code. And when I enable this plugin, it just works. The code in the plugin is x64 emulated, but it works seamlessly in the same process as the rest of the app thanks to the engineering in Windows 11. So even with a plugin that's outside of your control as a developer, your app can be ARM native while keeping compatibility with x64 code by using ARM64 EC. Well, now that we've gone into depth in the strategy and talked a bit about ARM64 EC, let's talk about how to get started. And so here's the crucial thing to know. If you can build for Windows, you can build for Windows on ARM, really. And so what I'll run through here is what specific additional information you might want to know, and it's not a ton. I won't talk about really building for Windows, just the delta of what it means to build for Windows on ARM. And so I'll talk through installing the right tools, planning for dependencies, a caution about architecture-specific code. I'll talk about setting up a dev test environment, and then finally adding that ARM64 configuration to your project. And so at the most basic level, to build an app for ARM64, you need something that can generate ARM64 code. You need tools. If you're building traditional ARM64, you have a lot of options at this point. MSVC has supported ARM64 for both Win32 apps and store apps since Visual Studio 15.9 that was released in 2018. You just need to add the ARM64 tools in the individual components, and then you can build ARM64. Now, .NET is a more recent option for building ARM64 apps. With .NET 5.0.8 or higher, you can build ARM64 .NET apps, including ones that use WPF or WinForms. And if you're using Clang and LLVM, that's also supported for building ARM64 and has been for a while. In fact, that's how Edge, Firefox, and others, including Electron-based apps like Teams, are built for ARM64 today. And you can even get a native version of LLVM itself for ARM from Linaro, who've been helping to make sure all sorts of tools and projects are available for ARM. Now, the story for ARM64 EC is a little bit different right now. It's still in preview, so you should grab the latest version with Visual Studio 2022. And also, as a result of being still in preview, it's only currently available with MSVC. So if you use a different compiler, you can't generate ARM64 EC code yet. To add the ARM64 EC tools, you install them the same way you would add the ARM64 tools. Just look under individual components for ARM64 EC, and you'll see the checkbox to check. You'll also see that it currently shows up as experimental, reflecting the fact that this is still in preview and that we could really use your feedback. And now I want to talk a bit about dependencies, because this has been a major challenge for a lot of people building for ARM. And that's because if you are building ARM64 version of your app, you need ARM64 versions of the app's dependencies. And this, many of these dependencies are already available. They've been built for ARM64. There's been huge progress, even in the last year, as the ecosystem of apps and more developers build their projects, their apps, their tools for ARM. But for the ones that aren't available, how you solve that problem depends a bit on the source of the dependency. If you have dependency that you built in-house, that's going to be something that you'll want to build those dependencies as ARM64 as well. For third-party dependencies, you want to reach out to the ISV and ask for ARM64 support. They might have it already, and if they don't, you might not be the first person to ask. And that's going to help bump up the priority, make the ARM support come sooner, so definitely recommend it. And similarly, for open source dependencies, you might find that others have added support, and possibly a newer version has that support. If not, you might be able to add it yourself. That depends on the open source community's contribution guidelines, but it's usually an option. And then finally, If you have out-of-date dependencies, this might be an opportunity to look into replacing that dependency entirely, especially if it's not being maintained anymore, since you can imagine that eventually there's a liability for security issue. Now, with ARM64 EC, the picture changes somewhat. You'll want ARM64 EC versions of your dependencies, not ARM64. But you can fall back to using x64 versions of any dependencies, including ones that are statically linked, so that the code in that dependency will then run under emulation, while the ARM64 EC parts of your app run natively. Then after dependencies, the other general caution or category or bucket of things to look out for is architecture-specific code. And this is because there's a lot of Windows code out there that assumes that processors always look like x86. After all, those assumptions were valid on Windows for a long time. And so on the right, I've singled out a project where the piece of code shown, it builds, it works fine, it works great for x64. But for ARM64, it doesn't even build, much less run. And you can see that's because it's looking for the RBP member of this processor context. And that doesn't exist for ARM64. I mean, that's not what ARM64 registers look like. And this should have had an if-def for x64 because it is architecture-specific code that was hiding in plain sight because this was only built for x64. Taking that a step forward, assembly code is, of course, dependent on the processor. And so if you have a lot of assembly code, you want to make sure you have versions of it for ARM, or use a C fallback in the meanwhile and then port it later. Similarly, compiler intrinsic functions are also dependent on the processor. You'll want to find any usage of x86 Intel intrinsics and move them to ARM64 compiler intrinsics. There are some great guides and tools out there to assist in that effort, particularly if you're moving from SSE SIMD instructions over to Neon. Now, it's worth noting that ARM64 EC is, again, a little bit different, and because it allows you to use x64 compiler intrinsics, and that's meant to facilitate porting and make it easier to build your whole project as ARM64 EC. But you'll still want to move to ARM64 compiler intrinsics for the best performance in your ARM64 EC code. Then finally, as a bit of a generic warning, you might find some strange runtime behavior if you have code sprinkled throughout your projects that assumes only two architectures in the world have ever existed. And this is somewhat common. For example, you might find places that check the architecture by, and then follow some logic like, if x86, do this, else assume x64. Then another place in that same code base might do the opposite. If x64, do this thing. Otherwise, else assume x86. And that sort of logic works fine when you only have two architectures in the world, but it struggles with a third architecture like ARM64. In this contrived example, you'll be on the else path in both cases, and that may lead to undefined behavior, weird situations. So in general, it's worth taking a look anywhere your code is checking for the architecture or it has low-level dependencies on how the processor works. That's just something to look out for. But let's move past the caution tape. We can talk about the dev test environment. Whether you have a fully built ARM64 binary or you just want to try an existing x86 or x64 app under emulation, you'll at some point want to run on Windows on ARM to make sure it works. And to do that, you'll need ARM64 hardware. Now, not everyone has access to these devices right now, so that can certainly slow down progress. The good news is that within the last year, there are now all these great low-cost device options available that should help to reduce that barrier. I mentioned the Snapdragon Developer Kit, but that's not even the only option out there. There are also OEM devices available. Additionally, Windows on 11 on ARM supports Client Hyper-V, which means a Qualcomm device, like the Surface Pro X, can run an ARM64 VM. And having a VM available makes it much easier to have a repeatable environment for something like installation testing or debugging. And so that's really useful and really handy when you need some sort of environment to set up. As for the setup itself, we generally recommend a cross-compilation setup using remote debugging. And so you would build on your desktop device, then deploy to your ARM device and remotely debug. And this allows you to use an existing dev setup that you're comfortable with, but you're still able to build and debug on these new devices. You should also know that if you need to do kernel debugging, it's supported with these devices, specifically via KDNet over USB that we have instructions for in our docs. WinDBG also supports ARM and has for a long time, but if you're a sysinternals fan, I'll add that at this time last year, there were 5 sysinternal tools available for ARM64. As of last count, there are now 38. And so I've included this URL here that is a no-frills way to see the list of all the tools that are available and download just the sysinternals tool you need for ARM64. Now, if you've come this far, you know the strategy, you generally know what to do, but you might be wondering a very basic question. Where's the ARM button? In Visual Studio, if your project has x86 and x64 configuration options and you don't see an ARM64 one, you can add it in the configuration manager as shown. And when you create the ARM64 platform for each project and then build the ARM64 configuration, that's it. You're building ARM64 code. And in the same way, if you've installed the ARM64 EC tools, you can add an ARM64 EC configuration to your projects and get started building ARM64 EC code. Similarly, if you use CMake in Visual Studio, you can take a similar step, hit the green button, and add an ARM64 configuration. And with that, you're well on your way to building an app for Windows on ARM. So I want to say thank you for coming and listening to this talk on building for Windows on ARM. The platform continues to evolve and develop, and I'm really glad you're here because you being here is how the platform continues to evolve and develop. And now that you've reached pretty much the end of this talk, my request to you is give Windows on ARM a try and test out your apps. If you don't already have ARM64 support, think about planning it out. Plan out what it would take to add that support to your app, to your dependencies, to anything you own. If you want a deeper look into building for Windows on ARM, I'd recommend taking a look at Marcus's talk, Developing and Debugging for Windows on ARM. You can also check out our developer documentation on Windows on ARM at aka.ms/Windows on ARM. You can also reach out to woafeedback@microsoft.com, WOA being, of course, Windows on ARM, with any feedback on the tools, the development, Windows on ARM. You can also tune into Hari's talk on developing for the next generation of Windows on ARM to learn more. And with that, I want to say thank you again, and I look forward to seeing all of your apps running beautifully on Windows on ARM in the future. Thank you. There's a live Q&A session starting now to continue the conversation. To take part, join us on Zoom, which does have a native version for Windows on ARM, by clicking the yellow button just below the video player on the sessions page.